and came home, fell asleep, and then I woke up. I was like, oh, crud.
Okay. So,
Yeah.
what are we going to work on tonight?
Tonight's just kind of going over stuff like trigonometry and the unit circle. I don't really have any specific homework because we just took our tests.
Okay.
So if there's any important topics you think I should really know in depth or
I'm sorry,
anything.
what?
If there's any important topics or things I need to really know in depth, we could go over
Well, I can
stuff.
certainly test you on the unit circle.
Or I'm taking the ACT in February if we could go over a couple questions there too.
Okay, we can also do that. I've got plenty of ACT tests on my computer. Before we leave Trig, how far have you gotten in Trig? What's the last thing you covered?
Just finish unit circle, area of a sector, area of a segment. We're just going to start looking at like the equations of trigonometry and such.
The identities?
Yeah.
Let's go over,
Yeah.
let's go over a few of those before we turn to ACT.
Okay.
There are basically 11 identities that you absolutely have to know. What's the
Okay.
reciprocal to sine?
Cosecant,
What's the reciprocal to cosine?
secant,
What's the reciprocal to tangent?
cotangent.
Those are 6 of them, because obviously cosecant must be equal to 1 over sine also, right?
Mm.
So there's 6 identities. And there's really 11 that you absolutely have to know for what's coming up.
Okay.
These 2 are called quotient identities. What's the tangent of x equal to relative to sine and cosine?
The tangent of x equal to relative sine and cosine?
It's sine over cosine.
Sine x over cosine. Okay.
In other words, all trig functions are going to have an angle. It doesn't mean
Okay.
anything if I just say tangent. If I forget to write it sometimes, it's just because I get tired of writing it over and over. But
Yeah.
when you take a trig function, you are taking it of an angle. It would not make any sense at all to just say tangent equals. But in other words, what this says is the tangent of 30 degrees is equal to the sine of 30 degrees divided by the cosine of 30 degrees.
Okay.
And if you haven't had this one yet?
No.
Okay, that's good. I'm going to give them to you. I'm going to get you a little bit ahead in trig, just because it'll be helpful to you.
Okay.
Now, let's prove that the tan of 30 degrees is equal to the sine of 30 divided by the cosine of 30. Well, we know the tangent of 30 is 1 over root 3, right?
Okay.
Well, the sine of 30 is 1/2. Cosine of 30 is root 3 over 2. I get this answer by flipping the denominator and multiplying, and I end up with 1 over root 3.
Okay, yeah.
Now, clearly we could rationalize that if we need to.
Mm-hmm.
And, I have another student, all my pre-calc students are now in trig, and one of them has a teacher that told him, do not worry about rationalizing these things in trig. Trig is all about ratios. There's nothing wrong with this answer right there.
Okay, yeah.
Okay?
That's what my teacher said too.
Oh, good, because I love that. That's the best thing I've heard about trig from a trig teacher in a long time. If you were to rationalize it, it's equal to square root of 3 over 3. But if you put these things into a calculator, you'll get exactly the same number all the way down to the 9th decimal place. So they're the same number. The only reason mathematicians ever decided that you need to rationalize the denominator, I think, is because it doesn't make sense to divide something up into an irrational number of parts. I can divide something up into 2 parts or 3 parts or 7 parts, or even I can divide something by a half. But how do you divide something by 2.7189, a decimal that goes on and on and on and on forever? So that's where the whole convention of rationalizing denominators comes from, I believe. But when you get to trig, you realize that because so much of trig is reciprocals, that the moment I rationalize that, now if I'm talking about cotangent, well, I'd rather I hadn't rationalized it.
Yeah.
In other words, if tangent's 1 over root 3, that means cotangent is root 3 over 1, which is great. If I rationalize it first, and now I try to figure out cotangent, well, that's 3 over root 3, and I got to rationalize it again to get 3. So with trig, a lot of times you're just kind of wasting effort by rationalizing it because you end up having to do it twice so frequently.
Okay.
Okay, so there are 2 quotient identities that you need to memorize. This is one of them. The other one, I'm not sure you need to memorize that. You can figure that out. What has that got to be?
Cosine x over sine x.
Yeah. In other words, these 11 basic trig identities, including the first 6, is all you really need to do is memorize these first 3, right? And you have these second 3. You can figure them out. Same thing with the quotient identities. And then there are 3 Pythagorean identities. This one being the most important one, I guess. This is the one they teach you the first. Any idea what that's equal to? Always 1.
Okay.
In other words, if I took the sine of 30 degrees and squared it, and then I took the cosine of 30 degrees and squared it, and I added those 2 numbers together, I'm going to get 1. And if I did the same thing for 45 degrees, I'm going to get 1. Or any angle whatsoever, the sine squared plus the cosine squared is always equal to 1. So that's the most important one to remember. There are 3, and the next one is maybe the toughest one. I'm not sure why it's tough to remember, but it doesn't follow the same pattern. In other words, this one is tangent squared plus 1 equals secant squared. Okay? Work on memorizing that one, and of course that one. There's a third one that you can always figure out from the second one. And that is if I take the cofunction of tangent, which is cotangent, not the reciprocal, but the cofunction, that's also equal to the cofunction of secant squared, which is cosecant squared.
Okay.
In other words, you can always figure out this third one from knowing about cofunctions. Now, I'm not sure you've really studied cofunctions. Let's talk about them. They're really quite simple. What's the cofunction of sine? Stick a co in front of it. That's all you have to do.
Okay.
So the
So just
cofunction
be,
of sine is cosine. And it has this property. Likewise, the cofunction of cosine is sine.
sine. Okay, I see.
Also has this property. Remember that the sine of 30 degrees was equal to the cosine of 60 degrees.
Okay, yeah.
The sine of 20 degrees is going to equal to the cosine of 70 degrees. So
Okay.
cofunctions have this property. And to figure out which trig functions are cofunctions of one another, well, tangent is obviously cofunction of cotangent, and it
Mm-hmm.
also has that property. And finally, secant is the cofunction of cosecant.
Okay.
And these are different than the reciprocals. The only one that's the same is the tangent. The tangent is the only trig function whose reciprocal is the same as its cofunction.
Mm-hmm.
Now,
Okay.
so that's the definition of cofunction. And now if we go back up to these three what are called Pythagorean identities, they're called Pythagorean because everything's squared. Okay.
Mm-hmm.
Notice that the cotangent is the cofunction of tangent, still plus 1, and it's equal to the cosecant squared, which is the cofunction of secant squared. So you really only have to memorize those two to figure out the third.
Okay.
So of these 11 critical identities that they want you to not just memorize, but know like you know your name, you really only have to
Okay.
memorize 6 of them. There's 2 there. There's 1 here. That's 3. And there's these 3 here. That's
Okay.
so 6 out of the 11 is all you have to really memorize. But I would advise you that it's worth memorizing those and not forgetting them.
Okay.
Know those 11, it's called 6 reciprocal identities. There are 2 quotient identities, those 2, and there are 3 Pythagorean identities.
Okay.
Now that doesn't really count these cofunctions. That really actually comes later. The only reason I talked about cofunctions was because it helps to memorize this third Pythagorean identity.
Okay.
If you know about cofunctions, then the third derives from the second.
Okay.
That's the next thing that's coming for you in trig, are these. And then they're going to get into verifying trig identities, which is a lot of fun. I'm
Mm.
kidding. But it's fun if you know your 11 identities. And
Okay.
when they get to verifying trig identities, which I believe is probably the next section for you, um,
Mm-hmm.
there are no real problems in life that require you to verify trig identities. It's a
Okay.
totally made up math exercise, and its purpose is to get you to memorize those 11 identities. When you
Okay.
spend a week verifying trig identities, which is about what you'll spend, when you're done with it, I guarantee you'll know those 11 identities. Now, they could just drill you over and over and over with those 11 identities, but verifying trig identities is useful for solving trig equations also.
Okay.
When you have certain trig equations, let me just give you an example just because it's an interesting one. Sine squared of x minus cosine of x minus 1 equals 0. Now this is a trig equation, and solving trig equations is extremely here, let me make this +1, excuse me, if the trig functions are different from one another. One's got a
Okay.
sine and a cosine. So this is really hard to solve in this format. But what if I use the Pythagorean identity for this? That becomes 1 minus cosine squared of x. That's its identity. Remember, sine squared plus cosine squared equals 1. Therefore,
Okay.
sine squared equals 1 minus cosine squared. And then if I complete the whole thing, let me make that a 2. And I simplify this. It becomes cosine squared of x plus cosine of x. I wanted that to be a 1 in the first place, sorry. Minus
Hmm.
2 equals 0. And so by using the trig identity, I've converted the entire equation to cosine. And now notice what you're looking at is a quadratic.
Mm-hmm.
And I can solve this equation by saying, well, that's cosine minus 1 times cosine plus 2 equals 0. In other words, I can factor it.
Okay.
And then I have my answers. Cosine of x has to equal 1, or cosine of x has to equal minus 2. Well, this one can never happen because the range on cosine is always minus 1 to 1.
Mm-hmm.
So when you get an answer like this by solving a quadratic, it's an extraneous solution. So the solution is, where is cosine of x equal to 1? When x is 0 degrees. So there's
Okay.
the answer. So what I started with was a trig equation that had two different trig functions involved. And by using an identity, I was able to turn it into a quadratic, which I could factor and solve.
Mm-hmm.
Okay? So these
Okay.
11 basic trig identities cannot overemphasize the need to memorize those.
Okay.
All right.
Okay.
For now, unless you have any other specific questions about trig, we can go to ACT.
I don't think I do. I'm ready to go to ACT.
Okay, cool. And you're definitely taking the ACT in February.
Yeah, February 11th.
Are you going to take the SAT also?
I already took the SAT once.
Okay,
So my first score I got an 1170 on, and then I take it again in
April.
April. Yeah.
Yeah, I've got another student taking it in April. What'd you get in the math on the SAT?
I think I got a 560. 560. Yeah.
Okay,
Mm-hmm.
and so you must have done similar in the verbal.
The verbal I got a 610.
Oh, you did better in the verbal than the math. Okay, that's good. That's a good score, 1170. Uh,
Mm-hmm.
I think you could
I'm just hope.
I think you could do better in the math for sure.
Yeah, yeah. I'm trying to get up to like past the 1200 is where the goal is.
Yeah, for sure. Um, okay, let's look at ACT for now. There's not a huge difference between SAT and ACT. There
Mm-hmm.
used to be a considerable difference, but not so much anymore because the SAT changed in 2016. And
Yeah.
it turned itself a lot or very much more close to the ACT. So
Okay.
actually practicing for ACT or SAT is pretty much the same as practicing for the other. I believe that everything we've done has been SAT, correct?
Yes.
Okay. Now let's start ACT from my McGraw-Hill test 1. Now, all of the ones I have on here are, they tend to start pretty easy, the first 20 questions, and then they get difficult. So, might be a waste of time, but we'll go through these as fast as we can. If you get the right answer, I won't say anything. We'll go to the next one.
Okay.
Okay? Number 1.
That's 5, x equals 6. Or x equals b, sorry.
That's all right. 6 is fine.
Okay.
Number 2.
Consider 3 statements below to be true. That's around which of the following statements is true. G? Horse B is brown?
Yeah. Horse B is brown because it runs fast.
And fast.
And all horses that run fast are brown.
Are brown.
So horse B has to be brown if it runs fast.
Okay.
Let's talk about logic questions. There's one primary logic question. If P then Q means only one thing for sure. If not Q, then not P. Notice to reverse them. And the logic fallacy that most people make is when they hear if P then Q, well, they think if Q then P. But let me give you an example. If you live in Colorado, that's P. You live in Colorado, then you live in the U.S.
Okay.
Well, clearly the reverse is not true. If you live in the U.S., you do not necessarily live in Colorado, right?
Yeah.
So that shows you that if Q then P isn't always true. However, what is always true is if not Q, if you do not live in the United States, then you do not live in Colorado. That is a true statement.
Yeah.
Okay. So this is really the only one that you really have to know and know that that is really the only thing you can say. You cannot, sometimes if Q then P is true, you know, if I say if an angle is 90 degrees, then it's a right angle. Well, in that case, that happens to be true, the reverse. If it's a right angle, then it is 90 degrees. Okay, so sometimes the reverse of that is true, but this is always true. If an angle is not a right angle, then it is not 90 degrees.
Okay.
All right.
Okay.
Number 3.
Is number 3 A?
Yeah.
This should be, yeah.
In other words, how much greater is it? You just subtract.
Okay.
Hold on a second. How much greater? Okay. And I'm going to subtract x plus 5 minus x minus 2.
Let's just have to find the difference.
Well, but it matters which one comes first. If I do x minus 2 minus x plus 5, I'm going to get 3 as an answer.
Okay.
So it's important that you put the right thing on top and the right thing on bottom. If I say how much greater than 4 is 7, then you do 7 minus 4. You don't do 4 minus 7.
Okay.
And that's the way to figure these kind of things out, is just substitute numbers, and then it makes perfect sense which has to be on top and
Yeah.
which has to be on bottom. Whereas when they use variables, especially, binomial linear variables, it can be a little confusing. So the secret of that problem is just to make sure you put the correct thing above and below.
Okay. Okay.
About
Um,
number 4, let me blow it up a little bit. There you go.
the net amount of A in boxes having B of greeting cards given. So would the net amount be $30?
Yeah.
Okay.
And notice that you could have started this problem 3 sentences down. You could have
Yeah,
started
you don't.
reading at the 4th
Uh,
sentence and you'd have been fine.
yeah.
The first 3 sentences they give you there don't really give you any information. What they're
Yeah.
asking you to do is, what is A of 15? They're giving you this equation and they're saying, what is A of 15?
Mhm.
And you get used to that because these tests tend to do that a lot. In other words, they tend to give you a lot of information that you don't necessarily need.
Oh yeah.
Let me see if I just go to the right. Yeah, good. Hold on. I hate Windows sometimes. All right, number 5.
20 off a certain price. The carton of can 660. So you'd have to do. Oh man, excuse me.
Do you have a calculator in front of you?
Yeah, that's what I'm just
Okay.
doing real quick.
You should always
Is this
have.
the calculator section or not the calculator section?
This is the ACT, which is all calculator.
Oh, okay, cool. Oh wow,
That's
that's nice.
that's the one remaining difference between SAT and ACT, is the SAT does have a non-calculator section, but the ACT is all calculator. Unless they've changed it, I don't think they have. Um, so you're allowed to use a calculator on all of these.
Okay.
Tell me how you're going to do it.
So I'm going to take 6.60 and divide it by 10 to get 10%. Or, oh, there's an easier way to do this. Could I just take,
What do you think the most efficient one-step method of doing it is?
could I take 6.60 and multiply it by 0.8?
You got it.
And that gets me 528, so C.
Right.
So I was making too many steps.
Well, the typical student would take 6.6 and multiply it by 0.2 and then subtract that number from 660. And
Mm-hmm.
still get 528, but that's 2 steps. So whenever
Yeah.
you're taking discounts, always, if you multiply the original price by 1 minus the discount, you get the answer in 1 step. Likewise,
Okay.
if they're charging you a tax, let's say the problem was the sodas cost $6.60, but there's a 7% tax. Well, you could multiply 660 by 0.07 and add that to the price. That's the way most people do it. But the faster way would be to multiply 660 times 1.07.
Okay.
Okay, so with discounts and premiums, you can always do it in 1 step. Now, what piece of information did they give you in this problem that was completely irrelevant?
The carton of 12 cans of soda.
12. Yeah.
Yeah.
Who cares? They could have said
Uh-huh.
89, and it wouldn't have mattered. The price
Yeah.
is $6.60. We were trying to figure out what a 20% discount would give you. That's all.
Mm.
So another lesson is everything they give you isn't necessarily relevant. And that
Mm-hmm.
goes for the SAT and the ACT.
Okay.
Yeah,
The next one is K, 145.
good. How'd you get that so quick?
I kind of glanced at it while we were looking at the other problem.
Okay.
Yeah.
But it's an answer that definitely stands out, right? Because,
Oh,
I mean,
yeah, completely.
A was, you might even said A was 8 and B was 9. And
That's what I
the way
did, and then in
you
my
add
head,
those, you get 145, right?
yeah.
So how do they get all the other answers?
-8 plus 9, -9 plus 8, 9
In other
plus 8.
words, A is not actually 8. A is plus or minus 8.
Yeah.
B is plus or minus 9. So if you take all
Mm-hmm.
combinations of adding those, you can get any of those first four numbers, but you cannot get 145.
Mm-hmm.
All right?
Okay. In the figure below, midpoint of AC, what is the measure of angle BFG? 40 degrees, 180. Is it 140 degrees?
Yes. And hold on a second. More information that's irrelevant. I think. Yeah. The fact that B is the midpoint of AC,
It doesn't, yeah, it doesn't matter at all.
it's totally, this is a, you're going to get about 6 questions on parallel lines and transversals. Okay? And they're not all going to be this easy, the way I'm drawing it.
Uh,
If you know that you have 2 parallel lines and a transversal, then you know you only create 2 different unique angles.
yeah,
One is 1, that one's 2, that one's 1, that one's 1, that one's 2, that one's 2. And you know they're
yeah.
supplementary. So
Uh,
here we have the acute one, and here we have the obtuse one. They always have to be supplementary.
yeah,
And notice something else, that you could have not read any part of that and looked at the picture only.
and probably still gotten the
Well, yeah, the
question.
picture tells you everything that the paragraph gives you,
Yeah.
except that AC is parallel to DG. And that is
Mm-hmm.
vital information. In other words, that angle is only 140 degrees if AC
If
is
AC is
parallel.
parallel to BG.
But when you look at these problems, I'm surprised they didn't draw the parallel signs on there.
Uh-huh, the arrows.
Could have completely
Yeah.
ignored reading the problem and just answered the question. Um,
Mm-hmm. Okay. The next one, that's if x is -3 equals 9 minus, so wouldn't that be plus 18? Minus 18. So it'd just be 9?
about number 9.
So that's f. Okay, what is the value of 1 minus a?
Those are absolute value signs. Around.
Yeah, yeah.
Okay.
Um, I don't know if it'd be -11 or if it'd be 11. I think it'd be -11, right?
No, the definition of absolute value is always the positive answer.
Oh, so it'd be 11.
Yeah. In
Okay.
other words, the absolute value of minus 17 is 17. The absolute
Okay.
value of plus 17 is 17.
It's 17.
So the answer to an absolute value is always a positive number. If I said
All
absolute value is equal to -1, cannot be, impossible.
That's impossible? Okay. Okay.
Number 10.
If AB equals C and C equals KB and BC equals 0, then K equals, oh my gosh.
Sometimes it helps to write it out, and
Okay.
rarely pay attention to things like the BC is not equal to 0.
Okay.
Those almost always mean that you can't divide by 0.
Okay. Then K is equal to what? Huh.
Solve this
I'm
system of equations. If AB is equal to C and C is equal to KB, then what is
then AB is equal to KB. So then could I divide by B?
Yep. As
If I
long
divide,
as long as you know that B cannot be 0, you can divide by B.
okay, so if I divide by B, then I get A equals K.
And that's the answer, J. Yeah, these kind of equations you can always solve by dividing by the variable
Oh, okay.
in one instance. And that's where the variable might be 0. Okay, and this little thing they said where BC is not equal to 0, that means B is not 0 either. In other words, you
Okay.
can't multiply two numbers and get a non-zero answer and have one of the numbers be 0. If either B or C was 0, then this would be 0. So this statement they give you here tells you that B cannot be 0, which allows you to divide by B. Let me give you an example where you might not be able to do that.
Okay.
Solve that the same way you just solved the other.
6x squared equals x. Could I divide by x?
Okay, when you do that, you get this,
6x equals 1.
and then you get that as an answer, right?
So x equals 1, 6. Yeah.
You lost one of the solutions. Notice that one of the solutions,
Oh,
but
okay.
when you divide both sides by a variable and 0 is a possible answer, you lose it. It goes away. It disappears in the night.
Okay.
So in general, it's kind of dangerous to solve that equation that way, unless you are certain that x can't be 0. The way to really solve this is to subtract x from both sides. You get that. Now factor out an x. You get this. And that gives you both solutions. Either x is equal to 0 or x is equal to 1/6.
Okay.
So in general, you need to solve equations like, in general, be careful about dividing both sides by a variable unless you are 100% sure that the variable cannot be 0. It's only when
Okay.
it's 0 that it presents problems, and the only problem that it really presents is if 0 were a solution, you're going to lose it. You're not going to,
Okay.
okay? So the fact that they told you that BC was not equal to 0 means that it's okay to go ahead and divide both sides by B.
Okay. Okay.
It's 11.
X to the third
Yeah, okay.
times 13 is equal. Don't you just add them
You multiply.
or multiply them?
Here's the deal. Let's go through those rules. I'm going to use a common base of B.
Okay.
I'm going to make the exponent x just because this is the way I'm used to teaching it. Excuse me. If I'm multiplying, then I add the exponents.
Okay.
I always do one level less than what the bases are doing. I'm multiplying the bases, so I'm adding the exponents, which is one level less mathematically. If I
Okay.
have b to the x divided by b to the y, that's division going on, I'm going to subtract the exponents, one level less than division. And finally, if I have double exponentiation going on like that, well, I multiply the exponents.
Okay.
So these three rules apply whenever you have the same base. And just always remember that you never do the same thing with the exponents that you're doing with the base. In other words, the most common mistake to make here is to multiply the exponents instead of add them.
Okay.
And your mistake was adding them instead of multiplying them, which is okay. I mean, that's an easy mistake to make. But always know that you do exactly one level less, and addition is exactly one level less than multiplication. And I'm going to say that multiplication is exactly one level less than double exponentiation.
Okay. Okay.
Number 12 is kind of an interesting one.
If 2 over
X greater than or equal to 1/7. How might you typically solve that? Your first inclination to solve it.
Maybe to cross multiply?
Yeah, but notice the problem. I'm
not.
multiplying both sides by x. Well, it depends on whether x is positive or negative. If it's negative, I got to switch the direction of the inequality sign. If it's positive, I leave it the same, and I don't know what it is. Okay? So this is not the easiest inequality to solve. You cannot really multiply both sides by x. Okay? So there's another way to solve this. Notice what the question says. What is the largest possible value of x? Well, how about we try back solving it, which is a wonderful technique, as I've told you before sometimes. Sometimes back solving is so far superior to algebraically solving it. Notice how difficult this is to algebraically solve because I cannot multiply both sides by x. But back solving it, if I'm going to, what kids call check and guess, which is the first number I'm going to check?
Probably 7?
No, it says what's the largest possible value?
Oh, 28?
Yeah, start from the largest number because let's say you started with 7 and 7 worked, which it does. That would not tell you that it's the largest possible value. You'd have to try 14 also. And if 14 worked, you still wouldn't know. You'd have to try 15. So whenever they structure the question and they say, what's the largest, and you're back solving, always start with the largest number. Well, is that true?
Divided by 2, you get 1/14. No.
Okay. Let's go to the next one. Is this true?
No.
Go to the next largest one. Is this true?
Yes.
That's the answer.
Okay.
And I do believe that's the fastest way to get it, is to back solve it, not algebraically solve it.
Okay. Okay. Next one is circle. What's the circumference of 46 divided by cosine? Ooh. Doesn't sound so fun.
Huh?
I'm just sorry. I'm just mundane.
Does it look hard?
Kinda, yeah.
Actually, very easy. Reason it looks hard is because they've given you information you do not need. Let's draw a circle. split it up into 12 sectors. What's the measurement of each of those sectors? The angle. What's the measurement all the way around?
12 pi over 6.
No. What's the angular measurement in degrees?
Oh, 360.
Okay. So I've split it up into 12 sectors. What's the measurement of each sector? In other words, what's that angle right there?
Pi over 6? Oh.
Well, yeah, but give it to me in degrees because all their answers are in degrees.
30 degrees.
Yes. So what's the total measure of 5 of the sectors?
150 degrees.
Yeah.
Oh, okay.
Easy problem, right?
Why did they give you the circle with the circumference of 46 then?
Again, irrelevant information that they stick in there to try to confuse you.
Oh. Huh.
So you have to go into this test knowing they're going to do that very frequently. This is like the fourth problem we've run into where they've given you information you don't need. In other words, if they would have just said a circle is divided into 12 sectors, what's the measure of 5 of those sectors, you'd have gotten it in a flash.
Yeah.
What confused you was that 46 pi that had no bearing on the problem whatsoever.
Okay. Okay.
Let's skip 14. 14 is adding the 5 numbers and dividing by 5. I know you, know that's how you handle that. I won't make you do all that in your calculator. 15.
Huh. Wouldn't it be A?
Correct.
Okay, cool. I looked at E, sorry, I just looked at E for a second. I hesitated on that, and I was like,
no,
that doesn't make sense.
I was just going to mention that. What's the solution here? Forget their question. So if you tried to solve this equation and that equation alone, what would you get?
Wouldn't you get no solutions?
Yeah, because you get minus, you subtract x from both sides, and you get minus equals 3, which is impossible. Whenever you get a one number equals a different number, that means no solution.
Yeah. Okay.
So that can't be an answer. E. Hold on.
I'm almost confused on what this one is asking.
Yeah, again, they could have asked it so it wasn't so confusing. They could have said, what is 7 minus 2 times x minus 10 equal to? In other words, what they're asking is this. What is this equal to? In other words, simplify it.
So it becomes negative 2x minus, or plus 20x plus 7, so that'd be negative 2x plus 27.
Let's start with the 7. Now let's distribute the minus 2. So you get minus 2x, and then you multiply the minus 2 times minus 10, and you get plus 20.
20, yeah.
Now when you simplify that, you get minus 2x plus 20.
Plus 27, yeah, that's what I got.
That answer's on there, so the only thing that was really confusing was the first 3 words, for all x.
Yeah, that doesn't even make sense.
Well, it does actually. In other words, for all x, this expression is equal to this expression. There's no values
Okay.
of x where they're not the same. And that's all they mean by that.
Okay.
Okay. But again, another example of where they give you information that doesn't help, only confuses a little bit.
Okay. So if 60% of x equals 90, then x equals,
Now, before you answer, before you dive into the algebra, trying to figure out how to write that as an equation,
okay.
look at the 5 answers. What's the answer?
Wouldn't it just be 15?
Well, is 60% of 15 equal to 90?
60% of 15. No, I don't think so.
Okay, then it's not 15.
Okay. 60% of x equals 90.
In other words, you can still back solve it. This is a great one to back solve. You don't need to back solve it. It's a simple enough equation, but back solving solves it the quickest, in my opinion. So 60% of which of those answers is equal to 90?
So you'd write,
Well,
you'd take like,
just look at the answers.
and wouldn't it just be 150 then?
Yeah. In other words, it's got to be a number bigger than 90, right?
Yeah, but it can't be a number too obscure.
Well, it can't be 1,500. 60% of 1,500 would be 900.
Yeah.
So I can eliminate the first 3 because we know that it has to be bigger than 90, and so that eliminates it to D and E. Now you just have to get your factors of 10 right. But if I'm solving it algebraically, of means multiplication. So 60% times x equals 90. Now I divide both sides by 0.6, and I get 150. When I divide 90 by 0.6, I get 150. So you can do it algebraically, but I noticed that there was a little stumbling on figuring out how to write that algebraically, as it frequently is. It's frequently far harder to algebraically solve these problems than it is to back solve, especially because the ACT is kind of famous for giving you answers that are so far apart, you don't need a calculator. In other words, if I said, what's 90 divided by 0.6, and your only answers are these answers, well, you'd come up with 150 in a flash.
Mm-hmm.
They had 150 and 160 and 140 on there, then you might need a calculator. But they don't. They don't have anything that's within a factor of 10 of the correct answer.
Okay. All right, I understand that one.
We got time for one more. Let's do one of these. Oops, hold on. Boy, don't dare. Moment, adjust the size of your screen. Oh, now I'm going to have to go down. It pops down to the lowest resolution. Okay.
Okay. Price of one box of popcorn, one drink the other is $5.10. Price of popcorn, one drink the other is $8.35. What is the cost of one drink? 2 boxes of popcorn. So wouldn't you do 5 first? So starting out, wouldn't you do 510 divided by 2 equals?
No, they're not necessarily equally priced.
Okay.
However, if you take your girlfriend to the movie and you got to have 2 boxes of popcorn and 1 drink, as opposed to you go to the movie by yourself and you buy 1 box of popcorn and 1 drink, what's the price of that extra box of popcorn?
Oh, so the price of the extra box of popcorn is $3.35. $3.35 or $3.25.
Okay, now go back to the first sentence. If popcorn is $3.25, what's one drink cost?
5. Oh, whoops, quick. Minus 3. 185. Okay, I see how that.
Again, there's not anything even close to $1.85. So you can use the calculator to get this, but you don't need one because you can certainly subtract 510 from 835 easy. And subtracting 325 from 510 is somewhat difficult, but not when they give you these answers. That's got to be G.
Yeah. Okay.
All right.
Oh.
Nick, I got a 7 o'clock. I got to run to, so I'm going to let you go.
That's okay. Thank you very much.
But I will make a note that we got through 18.
On just one note. The next 2 Thursdays I have
3 o'clock appointments?
Can I make those 3 o'clock appointments?
No.
Or wait, I don't.
The next 2, sorry, Mr. Klein, sorry, it's me.
No
The next 2 Thursdays, he has games we didn't know about at 5 o'clock, so we need to cancel those Thursday appointments in February, the first 2.
I can do that real easily right here.
Okay, and I didn't know if you had anything open on Wednesday, the Wednesday before at 3.
Let me cancel these 2.
Okay.
So
sorry about that.
No problem at all. That's the beauty of online tutoring, actually. It's easy to cancel and reschedule. There's my Wednesday. You're looking at it. For February.
3. Just go 3.
Yeah, the 3 o'clock's fine. He'll just race home from school.
Okay, you want to make it 3:15? I can do that.
Yeah, that's perfect. That would be perfect.
All right, hold on. Let me put him in here. And we'll put him at 3:15 on both of those Wednesdays?
Yeah, both of the Wednesdays.
Okay.
Yeah, lacrosse has started, so we're trying to juggle everything.
Yeah, no, I understand. It's the juggling is difficult. That's why.
Yeah, he wasn't supposed to play a game today, and then all of a sudden the coach threw it in on us, and I was like,
Oh, okay. All right, so I'll talk to him on Wednesday.
Perfect. Thank you so much. I appreciate it.
Thank you.
You're welcome. Talk to you then.
Okay. Talk to you then. Bye-bye.